AP Psychology students, and welcome back. Today we are going to be starting our discussion about the psychological science practices, so really focusing on research methods and data interpretation. Today our central questions are what biases impact our ability to think critically, right? So when we're talking about humans, it's really important that we are critically thinking about the information that we're getting. And then second question is, how do psychologists use the research methods to describe, explain, and predict human behavior? So when we're talking about psychology, right? In our previous video, we talked about all the different perspectives of psychology. People can have a different lens or approach through which they kind of view problems or look at situations or things that they like to study. And no matter what a psychologist is doing, no matter what perspective they look at something from, they are using the goals of psychology to kind of guide their work. So what are these goals? So the first goal is that we want to describe what a behavior is, right? What do we see people doing? What do we see kids doing? What do we see adults doing? What do we see men doing? What do we see females doing, etc. Then we want to explain why. So yes, you could describe what's going on, but knowing why it happens, right, can really help us then either A, predict patterns in the future, right? So when we see A happen, then B happens. And eventually, if we can start making lots of predictions, we might be able to positively influence or change behavior, right? So no matter what kind of psychologist you are, no matter what your perspective is or the lens that you focus on, your goals of psychology are going to be the same. Now, although these goals are the same, right, it's really important that we are aware of our own biases when we go to do psychological research. So a lot of times students will say like, oh, Ms. Schaefer, I knew that, or oh, psychology is common sense, or oh, yeah, that makes sense, after I tell them something, right? And so this is a problem because we have intuition as human beings, right? We have this sense of like what we think we know or don't know, or if something feels good or bad, or my gut feeling, like right or wrong. And a lot of times our intuition can be right, but it's not always right. And when we study human beings, we want to make sure that we are trying to get the most accurate depiction of what's going on possible. The errors that we're really prone to when we're studying human beings or doing research or trying to figure out the answers to a problem is hindsight bias, overconfidence, and perceiving order in random events. So I'm going to talk about each of those separately. So first is hindsight bias. So this is our tendency as human beings to believe after we learn the outcome we would have seen it coming. It's kind of like, oh, I knew it all along, right? So if I tell you something is true, then you're like, oh yeah, that makes sense. The problem is you don't actually know if that makes sense. It's really easy once I give you the answer for you to imagine why that's the correct answer, because you know it's correct, right? So this is the idea of hindsight bias, or kind of like thinking about like, oh, how hindsight is always 20/20, like best vision. Like if you look in the past, everything seems to make sense, but there's no way you could have predicted that during that time. The next error is overconfidence. So we tend to think we actually know more than we do, right? We have more confidence in the answers we give, our abilities, and our insights or our thoughts than is actually true, right? We're more often wrong than we think we are. And then the last one is that we like to perceive order in random events. Okay, so what is this? So humans, our brains, like to make sense of the world. We like the world to make sense. We like to make sense of the world, right? So everything should go in an order. Things happen for a reason. Because we like to do this, it's really easy to find patterns or meaning in things that have neither. Example of this, hot or cold streak in sports, right? And there really is no actual meaning in that streak, but we find a connection and we think it's a pattern. Or like another great example is superstitions, right? Where we like wear something or do something and something good happens and we think they're connected, but really it was just coincidence. Another example of this is like people thinking that like more babies are born on a full moon, or like people act strangely on a full moon. And one of the reasons this happens is because we have confirmation bias. So once we believe something, like more babies are born on the full moon, or people act strangely when there's a full moon, then we only tend to look for examples that match what we already believe. So we only look for times when people are acting crazy during the full moon. Like, oh, there's a full moon coming up, and then you start paying attention to all the craziness. But like, there's craziness every day, all day, right? We don't need a full moon for it to be crazy, right? But once we think something is true, we look for information to confirm it. Okay, so now that we know some of the errors that we might make, it's important to talk about then what kind of method we use to help ensure that these errors don't impact our research. So this is the scientific method. It's not different than what you've learned about in any of your science classes. It's just kind of applied to psychological science. So in studying human beings, the way that they think and the way they act, right? So the first thing is that science is a verb. So there are rules to science. You do science, right? And the first rule is that when you are creating a hypothesis, right? Your hypothesis is your if-then statement, what you think might happen, right? You kind of have a question about something. You're like, I wonder if cell phones have an impact on mental health. Okay, so that's your like interesting question, right? We're over here on our scientific method. That's your question. You formulate a hypothesis. If a student spends more time on social media, then they will have a lower happiness overall. Okay, so now I have a hypothesis, my if-then statement. The thing about it is that it has to be falsifiable. So what does this mean? It means that you have to be able to prove if the statement is true or false. Okay, an example here. If people spend more time with someone, then they will find them more attractive. Okay, so I have to be able to prove that this is true, that they see them more often, they find more attractive, or that it's not true. So I have to be able to say like, okay, they spend time with them and they find them less attractive. Your answer has to be yes or no. You can't just have a hypothesis that only has a yes answer, right? And that's called falsifiable. The next rule is that your study must be replicable. So you have to be able to do the study more than once, right? You can't just do one study one time and say, oh, this is true, right? And one of the most important things that when we are making a definition replicable, when we're making a study replicable, it's that we have that operational definition. So we have a very specific measurement of the variables in our study. An example of this is happiness. So if we go back to my social media example, I'm saying, okay, if students spend more time on social media, then they will have lower overall happiness. So how do I define happiness? So that the person who recreates my study, who replicates it, can use the exact same definition, right? I could make it on a rating. So they rate their happiness from 1 to 5. I could also observe them and like count the number of smiles they have in 10 minutes in a conversation, right? It doesn't matter what your definition is. It just needs to be a specific measurement, a way that you are measuring the variable. And our third rule is that studies must be peer reviewed, right? So what does this mean? It means that you have to submit your study and you have experts, other psychologists who look at it and kind of review it. Make sure that you use good methods. Make sure that you have good science. Make sure you don't have any biases included. Make sure that you thought of different possibilities, right? And that's called peer reviewed. And once it's peer reviewed, then it can be published and it's seen as more legitimate, right? Your findings. So when we go to do this research, right? You have our rules, but not all research looks the same. So there's non-experimental research and there's experimental research. Non-experimental research is used to describe or predict behavior. We do not manipulate anything. We literally just go and watch or talk or survey. We don't manipulate any situation, right? These are case studies, natural observation, surveys, and correlations. Experimental research is when we use to explain behavior, right? And this is when we manipulate one variable, and the only type of experimental method is an experiment. All right, remember to stop here and double check that you can answer these essential questions before ending the video. That's all for now, AP Psychos, and remember, psychology is flippin' awesome.